Hey, as promised, we finally get to trapezoids. Trapezoids, of course, are still in the quadrilateral family, so they still have four sides, but they are not parallelograms. Hey, somebody just took our cow. Well, let's get back to normal. Hey, there, now we're back to normal. Okay, so trapezoids. So I'm sure you kind of already have a good idea of what a trapezoid is, but we want to look at the formal definition that mathematicians think is really exciting. Of course, because it's a quadrilateral, you know it's got four sides. But unlike a parallelogram, it has one pair of parallel sides. And again, those little arrow marks tell you that those sides are parallel. Not that they're the same length, not that they're congruent, but that they're parallel. They are called the bases. Notice the base angles share a base, and so they're paired up. One pair of base angles on one base, the other pair of base angles on the other base. And of course, we've got other sides too. And so the sides that are not parallel, we call those the legs. And if the legs are congruent, we call it an isosceles trapezoid. Notice it has to be the legs that are congruent, not one leg with one of the bases, right? It has to be the two legs that are congruent. If we know the trapezoid is isosceles, we know the pairs of base angles are congruent. Or, if I know that a pair of base angles are congruent, then I know the trapezoid is isosceles. Now, you got to be careful in this one. Just because the diagonals are congruent does not mean it has to be a trapezoid. Right? Rectangles also have congruent diagonals. Squares also have congruent diagonals. But if you know it's a trapezoid and the diagonals are congruent, then you know it's isosceles. Or if you know it's a trapezoid and you know it's isosceles, then you know the diagonals are congruent. Mid-segment works just like a mid-segment on a triangle. We have to find the midpoint. In this case, instead of two sides of a triangle, the two legs connect those two midpoints. You have a mid-segment. And it is the average of the bases. Again, if I'm going too fast, you can almost pause and think before I share answers here. Angle A has to be 60. That's because we've got consecutive interior angles. Remember, I've got two parallel sides, and so segment AB is a transversal. Right? BC is one parallel side, AD is the other parallel side, so those make parallel lines. And so angles A and B are both interior angles, and they're between the parallel lines. Angle C is another easy one. Because it's isosceles, you know the base angles are congruent. Same for angle D. Because it's isosceles, you know they're congruent.
Turns out the remote was out of batteries.
Okay, mid-segment, you know it's the average of the bases. So I average the bases together. 12 plus 36 is 48. Average is 24. Of course, besides the geometry concepts, we need to mix in some algebra. So again, I know the mid-segment is the average of the bases. So 3x minus 2 has to be the average of the other two bases. So I've got 3x minus 2. And then to average the bases, notice I have to add them together. So I take the x plus 11, add it to the 3x plus 3. Combine like terms in the numerator. X plus 3x is 4x. 11 plus 3 is 14. Divide everything by 2. Right? 4x divided by 2 is 2x. 14 divided by 2 is 7. Of course, I want all my variables on one side of the equation, so I'm going to subtract 2x from each side. And then I'm going to add 2 to each side. I've isolated the variable. I now know x is 9. If I actually wanted to know each of the dimensions, I could just take that value of 9 and plug it into each expression. Okay, so it's time to start. We're going to do the worksheet first, and then there'll be an IXL, and well, that's unusual. There's a spacecraft, but there's no cow for it to. Oh, it's returning the cow. Thank you, spacecraft. All is good in the world. The cow is back in the pasture.